Everyone's used their laser cutter to engrave a design. When you do, you usually end up putting a pocket into the material, and the bottom of the pocket has grooves or laser lines. A common trick to avoid laser lines is to defocus the laser. That can work pretty well, but fine-tuning it can be kind of tedious. It's very sensitive to your settings. In this video, I'll show you how you can get fast, crisp, high-contrast laser engravings like this one using a little-known trick called a shadow mask. The reason that simply defocusing your laser can be finicky is really just the spacing between the engraving lines. A very common line spacing is 0.1 millimeters, so that each millimeter of vertical engraving has 10 lines of actual detail. When the laser is focused like normal, the engraving lines don't overlap much, if at all. This is why you get noticeable grooves at the bottom of the engraved portion. The laser burns away each line, and the edges of the beam, or the overlap of the beam, have different intensities, and therefore burn to different depths, leaving a ridge. But when you defocus the laser, the overlap becomes much more significant. The result is that the wood doesn't heat up enough to instantly vaporize, and subsequent passes just dump more energy into the wood. Eventually it chars or even catches fire. Because the wood has absorbed the heat without vaporizing, the cumulative effects of the laser are different than the normal effects. Small changes to power don't lead to the normal small changes in engraving depth. The additional energy instead adds to the previous energy, and the power-to-char relationship ramps up faster, producing difficult-to-control behavior. Instead of simply playing with power levels, the first step to getting good defocused engraving is to space the engraving lines further apart. Simply switching from 0.1 millimeters to 0.5 millimeters, or 2 lines per millimeter, produces much better results. The laser beams still overlap a little, but the fuzziness at the edges blends together better. For my laser, I'm defocused down to about 1.5 inches, or 35 millimeters, using a speed of 400 millimeters per second and 30 watts of power, which is 30% on a 100 watt tube, and that seems to work just fine. You'll notice that the edges of the engraved portions of this circle are not crisp. They're as fuzzy as the laser beam itself is at this distance. If you try to engrave like this, your design is a blurry mess and looks kind of like a mistake. But a simple trick is to split the design into 2 parts. One part is a shadow mask, which blocks the laser beam, and the other is the fill, which actually engraves the material. Here I'm using scrap acrylic to make a smiley face shadow mask. The shadow mask blocks the laser beam just enough that the portion under the mask is unengraved. The shadows are defined by the edge of the mask, not the edge of the beam, and so they're perfectly crisp. You can use lots of different things for shadow masks. Here I'm using masking tape. One circle is just stuck on, and the other is cut and weeded in place. In-place masks leave a borderline around the design, which makes it look like an inlay. You can even get fine detail with shadow masks. Here I used a thin wood shadow mask to engrave text, and you can see that it comes out quite clean. This is technically a stencil, however, and you have to account for that in your designs. Since the shadow mask itself isn't entirely consumed in the engraving process, you can reuse them to mass-produce designs. I found that clear acrylic works extremely well for reuse and doesn't vaporize or char at all. This 1/8 inch shadow mask was used 10 times back to back, with no time to cool in between uses, and it only gets hot. There was no detectable change to the quality of the engraving, and the fine detail of the text didn't melt at all. Large patterns and longer times between engraving will extend the life of the shadow mask significantly. Thanks for watching.